The purpose of this activity is to find the mean, the 5-number summary, use a 1.5 IQR rule to check for any outliers, and to construct a box plot. We will also see the different ways finding the median and Q1, Q3 when we have an odd number of observations in the data set or an even number of observations in the data set. Number 1. Agricultural fairs often hold competitions for produce grown by local gardeners. The following data are the weight in pounds of 9 tomatoes entered into an annual fair in Roland, Manitoba, Canada in 2007. 0.96, 0.99, 0.94, 0.75, 1, 2.48, 1.15, 1.54, and 1.13. First, we observe that these numbers are not sorted in increasing order. There are 9 numbers for 9 observations. These numbers represent the weight in pounds of the tomatoes. For example, the first tomato weighs 0.96 pounds. The second tomato weighs 0.99 pounds, and so on. To find the mean, we will take the sum of all of these numbers. The mean is denoted x bar. We take 0.96 plus 0.99 plus 0.94 plus. We keep adding until all of the numbers appear in the sum. If there is a repeated number, we still need to add it to the sum. And then we divide it by the count. There are 9 observations. The numerator is 10.94. The denominator is 9. This is roughly 1.2156. The units for the mean is also the same as the units of these observations, pounds. This means on average the tomato weighs 1.2156 pounds. Next, to find the 5-number summaries, we need to sort the data in increasing order. We see that the minimum, the smallest number in the data set, is 0.75. The next number is 0.94. Be careful when we sort the number. The next number is 0.96 in increasing order. 0.99, 1.00, 1.13, 1.15, 1.54, and 2.48. 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 numbers. The 5-number summary consists of the minimum, Q1, the median, Q3, and the maximum in increasing order. We see that the minimum is 0.75. The maximum is 2.48 because we sorted the data in order already. This is a relative small data set, and so to find the median, we just pick a number in the middle, going 1 by 1, 1 by 1, 1 by 1, 1 by 1. We see that the number in the middle is precisely 1.00. Keep in mind that we can find the location of the median by taking n plus 1 divided by 2. N is 9, so this is 10 over 2, which is 5. The median is in the 5th location. 1, 2, 3, 4, 5, the 5th location. And in the 5th location, the observation has a value of 1. That value is the median. Notice that the median is not 5. Since the median is in the data set and we use it for the median, the data set now is divided into 2 equals half. The first half consists of 4 numbers and the second half consists of 4 numbers. Q1 is the median of this first half, but for this first half, there's no number in the middle. Thus, Q1 is the average of the two middle numbers in the first half of the data set, which is 0.95. Similarly, Q3 is the middle of the second half, but the second half have four numbers. There is no number precisely in the middle, so we would have to average the two numbers in the middle. Thus, Q3 is 1.15 plus 1.54 divided by 2, which is 1.345. Q3. Q1 is the 25th percentile, the median is the 50th percentile, and Q3 is the 75th percentile. There is no universal rule to find the percentile, and so if we use StatCrunch, we would get a different set of 5-number summary. If we use Excel, we might have different set of the 5-number summary. In this case, we did not include the number in the middle when we divide the data into 2 equals half, but some software packages, they might include the number in the middle in the first half and in the second half. Thus, don't be surprised if you have a different set of 5-number summaries. But if we are asked to use StatCrunch, then everybody should have the same set of the 5-number summary. If we're asked to do this by hand, then we should get the same set of 5-number summary. To use the 1.5 IQR rule to determine the outlier, we first find the IQR, which is the interquartile range. It is always Q3 minus Q1. Q3 is 1.345 and Q1 is 0.95. Thus the IQR is 0.395. 1.5 IQR is 1.5 times IQR, which is 1.5 times 0.395. This will give us 0.5925. We then find the lower fence, which is always Q1 minus 1.5 IQR. Q1 is 0.95 minus the 1.5 IQR is 0.5925. And this will give us 0.3575. The upper fence is always Q3 plus 1.5 IQR, but Q3 is 1.345 plus the 1.5 IQR is still 0.5925. This would give us 1.9375. This lower and the upper fence will help us determine any outlier. Any number that is less than the lower fence is an outlier. Our minimum is 0.75, which is the smallest number. There is no number in the dataset that is less than the lower fence. Any observation that is greater than the upper fence is an outlier. We see that the maximum is 2.48, which is more than 1.9375. This maximum is an outlier. We then check the next number from the left. 1.54 is less than 1.9375, so 1.54 is not an outlier. Since this 1.54 is not an outlier, we don't need to check the other observation because we know that they are less than 1.54. Since there is an outlier, we will construct a modified box plot. The box plot is the graph of the 5-number summary. Modify this if there is an outlier. Using the provided number line, we will graph or plot the 5-number summary. The minimum is 0.75 between 0.5 and 1. Q1 is 0.95, close to 1, but on the left-hand side of 1. Median is 1, precisely at 1. Q3 is 1.345, which is more than 1.25. The maximum is 2.48, but the maximum is an outlier, so we use the asterisk. We then draw a box around Q1 and Q3. Extend the minimum to Q1 by drawing a line in the middle. We then need to extend the line from Q3 to the maximum number in the datasets that is not an outlier. In this case, that number is 1.54. 1.54 is the largest number left that is not an outlier. We use the asterisk for the outlier 2.45. 1.54 is a little bit on the right hand side of 1.5. We extend the line in the middle of the box to 1.54. This is known as the modified box plots. What this box plot tells us is that from minimum to Q1, there are 25% of the observations in there. From Q1 to the median, there are 25% of the observations. From the median to Q3, there's another 25%, and from Q3 to the maximum, there's another 25% of the observations. This is a similar example, except that we now have an even number of observations, 10. There are 10 values, 10 observations, each represent the weight of the tomato in pounds. To find the median of this data set, we will sort the number in increasing order, but we notice that it is already done for us. The location of the median is still n plus 1 over 2, but n is 10 in this case, and so it is 11 over 2, which is 5.5. First location, second location, third location, fourth location, fifth location, sixth location. We notice that there is no 5.5 location. What that means is that we have two numbers in the dataset, but the median can only be one number. In this case, we would average the two middle numbers to obtain the median. Thus, the median is 1.00 plus 1.13 divided by 2, which is 1.065. Now, since the median is not a number in the datasets, we separate the dataset into 2 equals half. Thus, this time, Q1 is the number in the middle of the first half, which is precisely 0.99, and Q3 is a number in the middle of the second data set, which is precisely 1.54. The difference between this example and the previous one that we just did is that when we separate the 2 equals halves, earlier, if the number of observations is odd, we simply take out the number in the middle and divide the dataset into 2 equals half. But if the number of observations in the dataset is even, then we can evenly divide the datasets into 2 equals half. Also, in this case, the minimum is 0.75 and the maximum is 2.48. So the 5-number summary are 0.75, 0.99, 1.0625, 1.54, and 2.48. 5-number summaries are always minimum, Q1, median, Q3, and maximum.